The king of planets in the vast darkness beyond the warmth of the sun, past the rocky worlds and the gentle glow of the asteroid belt, there reigns a giant so immense that it dwarfs all other planets combined. Its name is Jupiter. Ancient sky watchers saw it as a wandering star, brighter than most and steady in its brilliance. The Romans named it after their king of the gods. Today, modern science confirms what mythology only hinted at. Jupiter truly is the king of planets. When we look at Jupiter, we are not simply looking at another world. We are witnessing a cosmic heavyweight, a sphere so massive that more than twice the mass of all the other planets in the solar system combined is contained within it. If the Sun accounts for nearly all the mass in our planetary neighborhood, Jupiter holds most of what remains. This immense bulk gives it power. In space, power comes in the form of gravity. Jupiter's gravity dominates the outer solar system like an invisible hand guiding the motions of countless objects. Asteroids shift their paths because of it. Comets bend around it. Even the orbits of neighboring planets subtly respond to its pull. Without Jupiter, the architecture of our solar system would look entirely different. Formed over 4.5 billion years ago from the swirling disk of gas and dust that surrounded the newborn sun, Jupiter grew rapidly. A small rocky core likely formed first, gathering material through collision and attraction. Then, once that core reached a critical size, it began pulling in enormous amounts of hydrogen and helium, the light gases that filled the early solar system. In a relatively short cosmic time, Jupiter became a giant. Its growth changed everything around it. The gas that might have formed other planets was consumed or scattered. The gravitational balance shifted. Jupiter did not merely join the solar system. It shaped it. From a distance, Jupiter appears serene, painted in bands of cream, gold, and rust. But those swirling stripes are massive storms, jet streams ripping through the atmosphere at hundreds of kilometers per hour. The most famous of these tempests is the Great Red Spot, a storm larger than Earth itself that has raged for at least 3 centuries. While Earth's storms come and go, Jupiter's fury can endure for generations. Beneath the clouds lies no solid surface. Jupiter is a gas giant, composed mostly of hydrogen and helium. As you descend through its atmosphere, pressure and temperature rise dramatically. The gas thickens, compressing into exotic forms. Deep below, hydrogen is squeezed so intensely that it becomes metallic, conducting electricity like a metal. This strange ocean of metallic hydrogen generates Jupiter's colossal magnetic field, the most powerful of any planet in the solar system. That magnetic field traps radiation in vast belts that encircle the planet, creating an environment deadly to unprotected spacecraft. Yet even in its hostility, Jupiter reveals beauty. Its magnetic field channels charge particles toward its poles, producing auroras hundreds of times more powerful than those on Earth. They dance endlessly, glowing in ultraviolet and infrared light, reminders that this giant world is alive with energy. But Jupiter's power is not confined to itself. Its true reign is measured by how it influences everything else around it. With a gravitational pull so strong, Jupiter acts as a cosmic gatekeeper. Countless asteroids share its orbit around the Sun, clustered in regions known as the Trojan asteroids. These objects are trapped in gravitational balance points, held there by the combined forces of Jupiter and the Sun. They are ancient relics of solar system formation, preserved under Jupiter's watch. Farther out, comets from the distant reaches of space often encounter Jupiter before they reach the inner planets. Some are flung outward, ejected from the solar system entirely. Others are captured into shorter orbits. In 1994, humanity witnessed a dramatic example of Jupiter's dominance when Comet Shoemaker, Levy 9, collided with the planet. Discovered by astronomers Carolyn and Eugene Shoemaker and David Levy, the comet had been torn apart by Jupiter's tidal forces before impact. Its fragments slammed into Jupiter's atmosphere in a series of explosions, leaving dark scars visible even from Earth. The event was a stark demonstration of Jupiter's gravitational might. It was also a reminder of what might have happened if such a comet had been on a collision course with Earth instead. This has led many scientists to describe Jupiter as Earth's shield. By attracting or deflecting dangerous comets and asteroids, Jupiter may have reduced the number of catastrophic impacts in the inner solar system. Early in Earth's history, impacts were frequent and violent. Over time, Jupiter's presence likely helped stabilize the environment, giving life a better chance to emerge and evolve. Without Jupiter, Earth might have faced far more frequent extinction-level collisions. Yet the story is not so simple. Jupiter's gravity can also redirect objects inward. Some comets that threaten Earth owe their trajectories to gravitational nudges from the giant planet. In this way, Jupiter can act not only as a protector, but also as a potential threat amplifier. It is both guardian and gambler, altering the odds in complex ways that scientists are still working to understand. The influence of Jupiter extends even to the stability of Earth's orbit. The gravitational interactions between planets can lead to chaotic changes over millions or billions of years. Jupiter's mass helps anchor the system, contributing to long-term stability. Simulations suggest that without Jupiter, the orbits of the inner planets might have been far more erratic, possibly making Earth's climate less stable over geological timescales. Climate stability has been crucial for the persistence of life. Thus, Jupiter's silent guidance may have been one of the unseen forces that allowed oceans to remain liquid and ecosystems to flourish. As we explore Jupiter with spacecraft, such as Juno, we continue to uncover new layers of complexity. Juno dives close to the planet's cloud tops, mapping its gravity and magnetic fields, revealing that Jupiter's core may not be a simple solid object, but a diffuse, fuzzy region mixed with metallic hydrogen. Each discovery reshapes our understanding of how giant planets form, not only here, but around other stars as well. Indeed, beyond our solar system, astronomers have found many hot Jupiters, massive gas giants orbiting very close to their stars. Their existence suggests that giant planets can migrate dramatically after formation. Some theories propose that Jupiter itself may have moved inward and then outward early in its history, a journey that could have sculpted the asteroid belt and influenced the formation of Mars. If true, Jupiter was not always where we see it today. It may have roamed before settling into its current throne. And then there is the question that has intrigued scientists and storytellers alike. Why is Jupiter sometimes called a failed star? To understand that, we must look deeper into what makes a star ignite. Stars shine because of nuclear fusion, the process by which hydrogen atoms fuse into helium under extreme pressure and temperature, releasing vast amounts of energy. Jupiter is made mostly of hydrogen, just like the Sun. It formed from the same primordial cloud, but it never grew massive enough. To ignite sustained fusion, an object must be at least about 80 times the mass of Jupiter. Jupiter has only about 1,000th the mass of the Sun. Though immense by planetary standards, it falls far short of stellar requirements. In its infancy, Jupiter likely glowed faintly with residual heat from formation, and even today it radiates more heat than it receives from the Sun. But it never crossed the threshold into true stardom. It remains in a middle ground, too large to be Earth-like, too small to be a star. A giant planet, powerful but not luminous, ruling by gravity rather than light. This is the paradox of Jupiter. It is a world that almost became something else, a near star that commands the solar system without shining like one. Its presence has shaped the destinies of planets, redirected the paths of comets, and perhaps helped make life on Earth possible. In the cosmic hierarchy, the Sun may be the undisputed ruler of energy and light. But in the realm of planetary power, Jupiter is the king, and its story is far from over. In the next chapter, we will journey deeper into the concept of the failed star, exploring the fine line between giant planets and brown dwarfs, and how Jupiter stands at the boundary between two cosmic identities. The failed star. To understand why Jupiter is often called a failed star, we must travel back to the violent nursery where our solar system was born. More than 4.5 billion years ago, a colossal cloud of gas and dust collapsed under its own gravity, forming the young sun at its center. Around it, a spinning disk of leftover material swirled like a cosmic whirlpool. Within this disk, particles collided, clumped together, and gradually built the planets. Among them, one growing world gathered mass at an extraordinary rate. That world was Jupiter. In those early moments, Jupiter had the same ingredients as the Sun, mostly hydrogen and helium, the simplest and most abundant elements in the universe. As Jupiter's core accumulated rock and ice, it reached a tipping point. Its gravity became strong enough to pull in enormous amounts of surrounding gas. The planet ballooned in size, rapidly becoming the dominant body in the young solar system after the Sun itself. For a time, Jupiter may have seemed destined for something greater. In the universe, the difference between a planet and a star is not composition, but mass. When a forming object becomes massive enough, gravity compresses its core so intensely that temperatures soar into the millions of degrees. At these extreme conditions, hydrogen nuclei begin to fuse into helium. This process, nuclear fusion, releases tremendous energy. It is the engine that powers stars, including our sun Jupiter, however, never reached that critical threshold. To ignite sustained hydrogen fusion, an object must possess roughly 80 times Jupiter's current mass. Jupiter grew large, but not nearly large enough. Its formation likely stalled as the sun's radiation and stellar winds swept away much of the remaining gas in the disk. The window of opportunity closed. Jupiter remained enormous by planetary standards, yet far too small to shine as a true star. Still, it occupies a fascinating middle ground. Astronomers have identified objects known as brown dwarfs, often described as failed stars. Brown dwarfs are heavier than Jupiter but lighter than the smallest true stars. They cannot sustain long-term hydrogen fusion like the Sun, but some can briefly fuse a heavier form of hydrogen called deuterium. These objects glow faintly, radiating heat left over from their formation. Jupiter shares similarities with brown dwarfs in composition and structure, but it lacks even the minimum mass required for deuterium fusion. In that sense, Jupiter is not quite a failed star in the technical definition. It is more accurately a giant planet. Yet the nickname persists because Jupiter sits so close to that boundary in cosmic terms. If it had accumulated dozens of times more mass, our solar system might have looked radically different. Imagine a binary star system, with two suns locked in gravitational embrace. The presence of a second star would have dramatically altered the orbits of the inner planets. Earth's climate, its seasons, perhaps even its ability to host life, might have been profoundly different. The fact that Jupiter did not ignite is part of the reason our solar system is stable and life-friendly. And yet, even without fusion, Jupiter is not cold or inactive. It radiates more energy than it receives from the Sun. This excess heat is a remnant of its formation, a lingering warmth from the gravitational collapse that built the planet. As Jupiter slowly contracts over billions of years, gravitational energy converts into heat, a process known as Kelvin-Helmholtz contraction. Deep inside, temperatures reach tens of thousands of degrees. The planet glows faintly in infrared light, invisible to human eyes, but unmistakable to sensitive instruments. Beneath its colorful cloud tops lies an interior unlike anything on Earth. The upper atmosphere is composed of ammonia clouds, water vapor, and complex chemicals that create its iconic bands. These bands are shaped by powerful jet streams, dividing the planet into alternating zones and belts. Storm systems churn constantly, driven by internal heat rising from below. The most famous of these storms, the Great Red Spot, has persisted for centuries, a colossal vortex large enough to swallow our planet whole. Descending deeper, pressure mounts to crushing levels. Hydrogen gas transitions into liquid, then into an exotic state known as metallic hydrogen. In this form, hydrogen's electrons move freely, allowing it to conduct electricity. This vast ocean of metallic hydrogen is thought to be responsible for Jupiter's immense magnetic field, generated through a dynamo effect similar in principle to Earth's, but on a scale far greater. The magnetic field extends millions of kilometers into space, forming a magnetosphere so large that if it were visible from Earth, it would appear larger than the full moon in the sky. This magnetosphere traps charged particles, creating intense radiation belts. When comets or spacecraft pass through these regions, they encounter some of the harshest radiation environments in the solar system. Yet this same magnetic dominance also influences Jupiter's moons, especially volcanic Io, whose eruptions feed charged particles into Jupiter's magnetic system. The interplay between Jupiter and its moons forms a miniature planetary system of its own, a complex gravitational dance that mirrors, on a smaller scale, the dynamics of the solar system itself. When NASA launched Galileo, it provided humanity with its first long-term, close study of Jupiter and its moons. Galileo revealed that beneath the icy crust of Europa may lie a vast subsurface ocean, kept liquid by tidal heating caused by Jupiter's gravitational pull. On Io, Galileo observed erupting volcanoes, the most active in the solar system, powered by the same tidal forces. Jupiter's gravity stretches and squeezes these moons, generating internal friction and heat. In this way, Jupiter does not merely dominate space around it. It actively shapes the geology and potential habitability of its satellites. The boundary between planet and star is not only a matter of mass, but also of influence. While Jupiter cannot shine like a star, it behaves like a central authority within its domain. Its gravitational field captures passing objects, sculpts orbital resonances, and stabilizes or destabilizes nearby bodies. Entire populations of asteroids are locked in synchronized orbits because of Jupiter's presence. Some regions of the asteroid belt are cleared out entirely, forming gaps known as Kirkwood gaps, where Jupiter's repeated gravitational nudges prevent objects from remaining. This gravitational sculpting is a reminder that Jupiter's role as a failed star does not imply weakness. On the contrary, it suggests a path not taken, a fork in cosmic history. Jupiter had the raw materials of stardom, but lacked the mass to ignite. Instead, it became something else, a giant planet whose gravity would govern the architecture of an entire planetary system. The line between star, brown dwarf, and giant planet is thin but decisive. Jupiter stands firmly on the planetary side of that line, yet it carries echoes of stellar ambition. Its story invites us to consider how delicate the balance of cosmic formation can be. A slightly more massive disk of gas, a slightly different timing of solar winds, and Jupiter might have crossed the threshold. In that alternate universe, the night sky above Earth, if Earth existed at all, would look very different. As we continue to study Jupiter with missions like Juno, we refine our understanding of giant planets, not only in our solar system, but across the galaxy. Each discovery about Jupiter helps astronomers interpret distant worlds orbiting other stars, many of which are far larger and stranger than anything we once imagined. In learning why Jupiter failed to become a star, we uncover deeper truths about how stars are born, how planets form, and how rare and precious stable systems like ours may be. Jupiter may not shine with nuclear fire, but its influence burns brightly across the solar system. It stands as a reminder that power in the cosmos is not measured only by light. Sometimes, the greatest rulers are those who shape destiny from the shadows, commanding with gravity rather than flame. In the next chapter, we will explore that command in greater depth, examining how Jupiter's massive gravity governs planets, captures asteroids, redirects comets, and quietly determines the fate of worlds, including our own. Gravity's dominion. Jupiter's reign over the solar system is not a matter of light or fire. It is a matter of mass and gravity, the invisible threads that shape motion and destiny. With a mass more than 300 times that of Earth and more than twice that of all other planets combined, Jupiter exerts a gravitational pull unlike anything else in the planetary realm. This pull extends far beyond its swirling clouds, reaching deep into the asteroid belt, across the outer planets, and even influencing the subtle wobble of the Sun itself. Jupiter's gravity sculpts orbits like an unseen hand, shepherding objects into stable patterns and ejecting others from the solar system entirely. The asteroid belt, a region of rocky debris between Mars and Jupiter, bears clear evidence of this control. Within the belt, gaps appear in precise intervals, known as Kirkwood gaps. These are regions where an asteroid's orbital period would resonate with Jupiter's, meaning it would complete a certain number of orbits for every orbit of Jupiter. Objects that enter these resonances experience repeated gravitational tugs, destabilizing their paths and often flinging them into the inner solar system or out into space. Jupiter's influence also protects the inner planets in a broader sense. Many comets, originating from the distant Oort cloud, are deflected or captured by Jupiter before they can reach Earth. Some are sent on harmless trajectories out of the solar system. Others are captured into shorter orbits, like the famous short-period comets that circle the Sun every few years. In 1994, the dramatic collision of Comet Shoemaker, Levy 9 with Jupiter demonstrated both the planet's power and its protective role. The comet had been torn apart by Jupiter's tidal forces, stretched into a string of fragments before plunging into the atmosphere. The resulting explosions released energy millions of times greater than the largest nuclear bomb ever detonated on Earth. Had this comet or a similar one struck Earth instead, the consequences could have been catastrophic. In this way, Jupiter acts as both shield and gatekeeper, a celestial body that governs the flow of potential threats. Yet its protective influence is not absolute. The same gravitational nudges that save Earth from some impacts can redirect other objects toward it. Some asteroids and comets owe their trajectories to Jupiter's pull. In this cosmic game of billiards, Jupiter can be both defender and provocateur. Its presence is a complex balancing act, influencing probabilities over millions of years. Jupiter's reach also extends to its family of moons. With more than 90 known satellites, it commands a miniature planetary system of its own. Some of these moons, like Europa, Ganymede, and Callisto, are locked in orbital resonances that are maintained by Jupiter's gravity. Europa, with its icy crust and subsurface ocean, is kept warm not by sunlight, but by tidal flexing, as Jupiter's immense gravitational pull stretches and squeezes the moon. Io, closest to Jupiter, is the most volcanically active body in the solar system. Its constant eruptions are powered by the tidal forces exerted by Jupiter and the gravitational interactions with neighboring moons. This dynamic illustrates that Jupiter's influence is not limited to shaping orbits. It actively molds the geology and thermal state of its satellites. Even Saturn, Uranus, and Neptune feel Jupiter's presence. The giant planet's mass has played a crucial role in stabilizing the orbits of these outer planets over billions of years. By anchoring the gravitational architecture of the solar system, Jupiter contributes to the long-term stability that allows inner planets like Earth to maintain relatively consistent climates and orbits. Without Jupiter, simulations suggest, the inner solar system could be far more chaotic, with higher risks of collisions and orbital shifts. Jupiter's influence is felt in the distribution of small bodies across the solar system. The Trojan asteroids, swarms of objects co-orbiting with Jupiter, remain trapped in gravitational sweet spots, known as Lagrange points. These points represent regions where the combined gravity of Jupiter and the Sun creates stable zones. Here, ancient rocks from the formation of the solar system remain relatively undisturbed, offering a glimpse into the primordial past. Beyond the asteroid belt, Jupiter's gravity can even shepherd comets and shape the paths of distant objects. Some bodies, nudged inward, become periodic visitors to the inner solar system. Others are flung outward into interstellar space, removed from the reach of the Sun forever. This interplay of capture and ejection demonstrates Jupiter's role as a cosmic traffic controller, maintaining order while shaping chaos. Jupiter's massive gravity also affects the Sun in subtle ways. The Sun does not sit perfectly still. It wobbles slightly in response to the orbits of the planets, primarily influenced by Jupiter's enormous mass. This solar motion, though imperceptible to us without instruments, is a constant reminder that Jupiter's presence reaches even to the heart of the solar system. The gas giant's power is not merely theoretical. It has been measured directly through spacecraft missions. NASA's Juno has mapped Jupiter's gravity field with extraordinary precision, revealing details about its internal structure, core mass, and even subtle variations in its atmospheric flows. These measurements confirm that Jupiter is not just massive. It is structured in a way that amplifies its gravitational influence across the system. In this way, Jupiter rules the solar system with quiet authority. It does not shine like the Sun, but it commands motion, stability, and destiny. Its gravity determines which objects survive, which are ejected, and which may collide with inner planets. Its presence has shaped the evolution of Earth and all life upon it. Without Jupiter, our solar system would be a very different place, perhaps more violent, perhaps less hospitable. In the next part, we will delve into the paradoxical relationship between Jupiter and Earth, exploring how this giant planet has both protected and threatened our world, influencing the emergence and persistence of life itself. Jupiter, protector and threat. The story of Jupiter's influence on Earth is a tale of cosmic duality. For billions of years, this massive planet has acted as both guardian and potential provocateur, its gravity quietly shaping the fate of our world. Early in the history of the solar system, Earth was a violent place. Collisions with asteroids and comets were common. Giant impacts reshaped landscapes, vaporized oceans, and left scars that would last for eons. Life, if it existed at all, struggled to take hold in such a volatile environment. Yet Jupiter's presence changed the odds. By dominating the orbits of comets and asteroids, it acted as a celestial shield. Many dangerous objects that might otherwise have collided with the inner planets were deflected, captured into orbit around Jupiter, or ejected entirely from the solar system. The comet Shoemaker, Levy 9 collision with Jupiter, observed in 1994, was a vivid demonstration of this protective role. The comet, torn apart by Jupiter's immense tidal forces, struck the planet with tremendous energy. Had it instead struck Earth, the consequences could have been catastrophic, perhaps even extinguishing early life. Jupiter's shielding influence may have been crucial in the formative epochs of our planet. By reducing the frequency of catastrophic impacts, it helped stabilize conditions on Earth, allowing oceans to remain liquid and climates to moderate. Over millions of years, this stability may have provided the essential environment for life to evolve and persist. But Jupiter's role is not purely protective. Its gravity can also redirect objects toward the inner solar system, sending some asteroids and comets on paths that cross Earth's orbit. Some near-Earth objects, including potentially hazardous comets, owe their trajectories to the gravitational nudges of the giant planet. In this way, Jupiter embodies a paradox, both defender and influencer. Its presence reduces some risks while increasing others. The subtle balance of its gravitational pull has profound consequences for Earth's environment. In addition to influencing potential impactors, Jupiter also affects the stability of Earth's orbit and climate over geological timescales. The giant planet's mass helps anchor the solar system's architecture, preventing wild orbital shifts among the inner planets. This gravitational stability has likely contributed to the long-term moderation of Earth's climate, allowing complex life to flourish over billions of years. Jupiter's impact extends beyond the realm of comets and asteroids. Its presence shaped the formation of the asteroid belt itself, preventing it from coalescing into a planet. It may have influenced the formation of Mars, leaving it smaller than Earth and Venus. In the grand scheme, Jupiter's gravity has molded the very layout of the solar system, affecting the potential habitability of every inner planet. Scientists continue to study these interactions through simulations and spacecraft missions. Observations of Jupiter and its moons by Galileo and Juno reveal not only the planet's internal dynamics, but also its role as a cosmic gatekeeper. Each orbit, each tidal interaction, and each gravitational pull contributes to the delicate balance that defines our planetary neighborhood. Jupiter's legacy is both protective and perilous, a reminder that in the universe, power carries responsibility. Without this giant, Earth's history might have been far more tumultuous. Yet even Jupiter cannot control every variable. Asteroids slip through gaps, comets are nudged inward, and catastrophic impacts still occur, though less frequently. The giant planet is a guardian with limits, an influential force without omnipotence. In understanding Jupiter's dual role, we see the subtle interplay between chance and cosmic order. Its mass, its orbit, and its gravity combine to create a system in which life on Earth is possible, but never guaranteed. The story of Jupiter is, in essence, the story of balance. It is a planet that wields tremendous power silently, shaping the fate of worlds with gravity alone. In its swirling clouds and immense magnetic field, in the orbits of its moons and the paths of distant comets, we witness the influence of a cosmic ruler. Jupiter did not become a star, but in the solar system, it rules in a different way, commanding not with light, but with mass, not with fire, but with force. As we study it, we gain insight not only into the planet itself, but into the fragile conditions that have allowed Earth to thrive. Jupiter is both a protector and a potential threat, a giant whose influence extends across the solar neighborhood, shaping the past, present, and future of our world. Its reign is quiet but profound, a testament to the power of gravity and the delicate balance of planetary systems. In the next and final chapter, we will explore Jupiter's broader legacy, examining its moons, its storms, and its magnetic power to understand how this king of planets continues to define the solar system today and into the future. Jupiter's story does not end with its gravity or its role as protector. Its influence reaches into every corner of the solar system, and its presence continues to define the architecture of worlds both near and far. The planet's majestic bands, swirling clouds, and storms are not merely aesthetic. They are manifestations of colossal energy, driven by the heat left from its formation and the dynamics of its deep interior. The Great Red Spot, a storm larger than Earth itself, has raged for centuries, a persistent reminder of Jupiter's power and longevity. Its bands, colored in hues of gold, white, and rust, are sculpted by winds exceeding hundreds of kilometers per hour, carrying energy across the planet in a rhythmic dance of zones and belts. Beneath these clouds lies the hidden engine of Jupiter's dominance, a core that may be diffuse rather than solid, wrapped in layers of metallic hydrogen. This interior generates the planet's immense magnetic field, the strongest in the solar system, creating a magnetosphere so vast that it envelopes entire moons and extends millions of kilometers into space. The magnetic field traps charged particles, forming radiation belts that can fry spacecraft electronics and make close approaches perilous. Yet these forces also generate dazzling auroras at Jupiter's poles, illuminating the planet's upper atmosphere in spectacular displays. The moons of Jupiter are another facet of its legacy. Over 90 satellites orbit this giant, each shaped in some way by Jupiter's pull. Europa, with its subsurface ocean beneath an icy crust, tantalizes scientists as a potential haven for life. Io's volcanoes, powered by tidal forces, create a ceaseless eruption of lava and gas, the most active in the solar system. Ganymede, the largest moon, is itself magnetically active, hosting its own mini-magnetosphere, while Callisto bears ancient scars of impacts, frozen in time. Together, these moons form a miniature planetary system, each body dancing to the rhythm of Jupiter's gravity. Beyond its immediate neighborhood, Jupiter's legacy is cosmic. Its presence stabilized the early solar system, allowing the inner planets to develop without catastrophic disruption. It sculpted the asteroid belt, captured Trojan asteroids, and even nudged comets in ways that determined which would threaten Earth and which would wander harmlessly into the void. By deflecting or absorbing dangerous objects, Jupiter has acted as an unsung guardian, indirectly nurturing conditions favorable for life on our planet. Yet it remains a reminder that power is double-edged. The same gravitational authority that shields can also redirect, sending potential hazards earthward. Its dominion is absolute in scope but nuanced in effect, shaping probabilities rather than certainties. As we look outward into the galaxy, Jupiter provides a template for understanding giant planets beyond our own solar system. Astronomers have discovered thousands of exoplanets, many massive gas giants orbiting other stars. Some even closer to their suns than Mercury is to the Sun. Jupiter teaches us how such giants influence planetary systems, how they migrate, sculpt debris, and govern the habitability of smaller, rocky worlds. It is a window into the universal principles of planetary formation and cosmic order. In the end, Jupiter is both king and storyteller. It narrates the saga of the solar system, from the chaotic collisions of its birth to the intricate dance of its planets and moons. It is a failed star, yes, but in its mass and gravity, in its storms and magnetism, it wields authority that no other planet can match. Jupiter rules not with light, but with force, not with flame, but with influence. Its legacy is written across the sky, in the motion of comets, the orbits of asteroids, the heat of moons, and the stability of Earth itself. To gaze upon Jupiter is to witness a cosmic monarch, a silent but relentless force shaping worlds for billions of years. It is a testament to the extraordinary power of gravity, the delicate balance of planetary systems, and the subtle conditions that made life on Earth possible. The King of Planets continues its reign, a giant in the darkness, reminding us that true power in the universe is not always luminous, but it is always profound. The story of Jupiter is far from complete. For as long as it spins, storms rage, and moons orbit, it will continue to rule the solar system in quiet, majestic authority, a colossal guardian and eternal king in a realm of light and shadow.